we are going to see today we are going to see the manual part programming for CNC turning centers. Okay, so previously we have seen a three-axis machine, that is a VMC, or having X, Y, and Z coordinates. So in this only two coordinates are there, that is X coordinate and a Z coordinate. Okay, so this is the Z and this is X. So when we give the feed for the cutting, if we give the feed for cutting, we give X direction, in X direction. Suppose this is the cutter, my cutter is there, and I'm this diameter of 30, then the direction will be in X direction, and the linear direction, that is when I move from the cutter from this position to this position, it will be in minus Z direction. Okay, minus Z direction. So most of the time, the center considered in this turning center means is a round bar is there. So the center is at this position, that is the center of that bar or the blank. Okay, so let's see different operations can be performed. I have we have to see today. Starting with this, we'll start with the plain turning operation. Then we will then we will include another step turning operation. Then again we will use a taper turning in that. Okay. Then threading, and then radius turning is there. Okay. So we'll see first separate operation performed. Okay, one by one, so that in the next lecture we'll see for okay. Okay, so in next lecture we will see in examination they will ask you the combination of 2 to 3 operations. That is, they will add a facing, then turning, taper turning is there, radius is there. Okay, that also covered in your that MP3 syllabus also, this turning operation. So that will be helpful for you. So I will add some other examples over this turning, so that any kind of problems asked in the examination, that will be easy to solve. Okay, so starting with the we will start with a simple turning operation. This turning operation, the problem given you is that a blank is given. That means I will first write this start one. Okay, so this is a simple turning operation is that. So bar stock is given. Bar stock, the raw material which is given for the machining, available is 50 mm diameter. 50 mm diameter. And you have to machine this up to 60, and length is also given. Some problems they will give you the length also. So for example, I am giving this. Suppose this length is of 80 mm, or 65 mm is the length. 65 mm. So 5 mm will be in the chuck, clamped in the chuck. So all the turning is done up to 60 mm, and the center is considered over here is this 0 0, where X and Z, X direction and Z direction. So working direction is this is your Z direction. This will be your X direction. Means when you give the feed, that will be X, and when you cut the operation in linear way, then it will be act as a working direction is a Z axis. Okay. So at this point, X is 0 and Z is 0. In some cases, U and UVW. So U and W is used in turning, and I for radius turning is there. Then I, J, K. So in this, two axes are there. So I and K is used. Okay. So that also we will see today. So this is your finished operation is that you have to bring this 50 diameter bar stock to 30. So bring the 30, and they will give you a number of cut also, or you can take randomly if they have not given you any depth of cut. Then you can take randomly for bringing this 50 diameter bar stock to 30 up to the length of 60. Okay, so with the program, first we have to start the basic codes 05. So G90, so that is for absolute coordinate system. We are considering this workspace as 0 over here. So G94 is that we are taking the feed rate in per minute. Then so so working axis will be G, X and Z. So XZ is the working axis code is I will check working axis code for just a minute. Okay. X and Z, G18. G18 is our working axis code. G18 we have to take because we are working at XZ direction. So previously we are taking XY plane. So now we are taking this G18. Okay. G18 and G71, that is in metric unit. All dimensions are in mm. Then G54, that is to save this work to 0. Okay. End of the block. Then next this N. Suppose the tool is given over starting position of the tool is over here. So they will give in this way. So it is at suppose in x direction it is in it is 60. Suppose x is 60. The starting point is 60, and the z is 10. Z is 10. Suppose. So we will take that. Okay. So G00 x 60 and Z 10, end of the block starting position. Okay, then before this line, there will be a selection of the tool first, and then we will go for the starting position. First, you have to select the tool. So T01 is the tool suppose, and M06 we have call for a tool chain, and that is to collect the in this the work for this tool holding device is a turret. Turret is there, indexable turret is used, or in case of VMC machines, drums are there for holding the tools. Okay, so 8 capacity, 6 capacity turret is there, 16 capacity, up to 30 capacity turret or twin turret is there. Okay, so 2 turrets are there for holding the tools. Okay, and in case of VMC, the capacity of the magazine, tool magazine, is about 100. Okay, up to about 100. And for VMC and for HMC, it will reach to 200, 250 capacity of tool, tool holding devices. Okay, so the magazine has the capacity of up to 200, 250. Okay, so so M06 we have called it for tool chain, and it will define the spindle speed. So M03 to start the spindle, and we're defining that speed is suppose we randomly I will take 800 is the RPM is the speed of the uh, spindle which carries the chuck. So this in this case now the workpiece will rotate. In the previous case, the tool is rotating. Okay, in this case, the workpiece is rotating. Okay, so yes, 800. Suppose speed I am giving 200. 200 is my speed. So I have started the spindle. You can also start the M. You can use over here M08 to start the coolant. M08. start the coolant. Okay, then this is N10, N15. For N15, I will bring this tool to this starting position. We have taken starting position SP. I have taken is that CF and 10Z. So for that, we will use G00, that is the traverse of the tool, to X60, and which is from this workpiece, the tool is 10 mm apart, in Z direction, and in X direction it is 60. So it should be how to decide the starting position. Suppose the starting position is not given in the problem, then it should be more than this bar stop. Okay. Then after this, now my tool is over this position. Now I have to bring that tool to this 00 position. To this 00 position. So N20, you can keep that again. Okay, and use X0 and Z0, X0 and Z0, X0 and Z0. Now my tool will move from this position to this position. Okay, in this way. If you want to keep some distance, you can take Z1 instead of 0. You can take 1. Okay, so that there will be no marking over here. So scraping will be off. So you can take Z1 so that it will remain, the tool will remain 1 mm apart from the surface of the bar stop. Then the first cut I will take that is of 30. So I will take suppose 650 mm diameter is given. So I will take 10 mm first cut. Again I will take second cut of 10 mm, so that this 50 mm diameter rod will change into this 30 mm diameter. Okay, so how to do it? 25 and 25. So it is a linear operation. So you have to use G01, G01. Okay, G01. You can bring the X G01 and Z0, G01. X will take diametrically X40, X40. So it will take diametrical, it will move 20 mm from this, but it will take diametrically dimension. Okay, so in this way it is programmed. Okay, X40, X40. So it will take diameter of 40. Okay, so now the cutter will move from this position to this position. So for the blank is in this way. Suppose it is a 50 diameter. Okay, now the cutter is at this position. Now the cutter is at this position. We are taking the depth of 10 mm, and the diameter it will cut will be of 40. So instead of this, you can take G00 or an X40. So there is no in cutting is done. You can use this G00, X40, and then end of block. Now the cutting will happen. So I will move this tool to cut this length in this way. Okay. So for that, N30 use, and for the series, and G01. Now the cutting will happen. So G01 Z minus 60. So now my cutter will move in this way. My tool will move in this way up to this point. Okay. Now this position will, now at this block my tool is over here. My tool is over here, and he had cut the 40 diameter. Okay, 40 diameter. Now the bar stock diameter changes to 40 mm. Okay, end of the block. Okay, end of block. Now next I have to bring this again. I will have to bring this again into to this starting position. Again this starting position. Then I will again change, come back, change and machine this 30 diameter. Okay. So for that I will use again N35 N35 G00, and the starting position I will use again X60, X60 and Z10. So in this way, the cursor will move in this direction, and it will come back to its starting position. I will again take the second cut N40. Now G00, don't write again. You can use the feed directly. X30. So now towards this depth. Okay. So X30. Okay. Now cursor will start the cutting. It will take now cutting N45, G01 and Z minus 60. Z minus 60. So in this way, now the cutter will move in this direction and it will cut the bar stop to diameter. Okay, so this completes. It will move over here. So now my cutter is over here. That is N45 block. My cutter is over here. We have completed the diameter of 30. Okay, now again I have to bring back the tool. Okay, so N50, N50, G0, G00, X60, X60, and Z10, Z10. Again, it will move in this way. Okay, in this direction. Okay, now N55, N55, G28. So that will be the homing position of your tire, G28. Okay, then after this, you have to stop all the means you have to stop the spindle. So for that N60 Yamaha 05, the spindle will stop, and to stop the coolant also N09. Okay, and in the block. And for the last N65, I will stop the program and program stop and restart. So learning operation is carried out in a manual part programming. Okay. So any questions regarding this, you can ask now. So moving ahead, the next taper turning. So instead of this, again, I will explain this later. So it is a how to take the multi-pass. So it is same as the multi-pass turning operation. It is similar to this first one. I will explain. Okay, I will explain this first one. So, so blank is given. So bar stock in this is a 40. Okay, 40 is our 40 diameter is given. So bar stop is of 40 mm diameter. Okay, then they have given you okay. Each time the tool is fed against the workpiece by 2 to 3 mm for rough cut. Okay, so in the problem statement, they have given you rough cut is given, rough cut of 2 to 3 mm. You can take anything. I will take the maximum 3 mm, 3 mm rough cut. Okay, then for the finish cut, they have given you finish cut. They have given you 1 mm. Okay, so you have to take 1 mm for the finish cut. So two different depth of cuts are given. Okay, for rough cutting, they have given you 3 mm. Okay, so from a bar up to 30 diameter, with a length 30. So you have to operate. Means suppose previously the bar stock is in this way. Okay, so it is a complete bar of 40 diameter of length 80. Okay, so you have to machine only this portion. To machine only this portion. Okay, and you have to take rough cuts of 3 mm, 3 mm, 3 mm, and last cut you have to take a finishing cut of 1 mm. So if we divide this, because the difference between this 40 mm diameter difference is there. So I will use 3 mm, 3 mm, 3 mm, total 3 cuts I will use, and then after I will use the finish cut of 1 mm. Okay, finish cut of 1 mm. So this can be this can be done by using do loop cycle also, but now time for the time being, we will use the simple means retracting position of this, and then after we in the next on Wednesday we will take a do loop or a turning cycle example also. At that time, we'll explain the code, and the code is used for that is, I think, the code used for that cycle, mm, trading cycle. Okay. So if the machine is of Fano control, then G71 is used at that time. In this, the turning code is, I think I have given you that. Mm, the code turning cycle. I think it is a 64 or something. 61 or 62 is that for the turning. At the time of that cycle, I will tell you, instead of the retracting position of the tool, you can use that code and you have to machine that part. So this retracting line of block will be eliminated. Okay, so we'll use the conventional way uh, as we used in the previous problem. So multipass, this is a multipass type of turning is there. So we require total four passes to complete this operation. Okay. So let's start again. Starting N05, N05, G90, G71, G94, then G18, G54. Okay. So this codes will remain same. That is for 71 is for metric unit, 94 is the mm per minute, feed using mm per minute. G18, that is the XZ coordinate, and G54 is the saving saving the work with zero over here. Okay. So so N10 we will use first. Suppose we will first decide the starting position. So starting position I will take as it is X. I will take starting position of the tool is 41, 42, and 2. 42 and 2 is my starting position of the tool. Okay, so it is just here. Okay, at this point 42 and 2. So it is 2 mm apart from the surface. This one. I will write the starting position over here. Starting position XP. X is 42 and Z is 2. So my tool will be over here. Okay. This is my starting position SP. And that first G0 instead of this, first you have to select the tool P01, P01, M06, M03 to start the spindle, then M08, and then speed you can decide anything, 800, suppose RPM is there, and the speed rate 300, okay, mm per minute, and 15. Now we have to call for the starting position X 42 and Z2. So now my tool is over this starting position, the induct block. N20 will be G. We have to set the first pass. So there are we required three passes, three passes. We required three passes of 3 mm. That is for rough cut, and pass of 1 mm. That is for finish cut. For finish cut. Okay. So starting with the first rough cut, we will give G00. You can delete, eliminate this. Don't write this because we have used in the previous line. So no need to write this 0 again. You can give the x coordinate. X so 37. Sorry, x 37. So my tool will move in this way. Okay, 3 mm. Okay, then diametrically it will move diametrically 3 mm. So 1.5 over here, 1.5 because it is a round one. Okay, so x in this way. Now we have to give the feed of cutting. So N25 G01, it is a linear. So distance is z minus. Okay, now it will cut this portion. It's the first cut. So this is my first cut. Okay. Again, I have to bring back the tool to its static position. Again, I will use N30 G00 X42 Z2. Okay. So if we use this turning cycle, that is the G61 or 62 code is there. So if we use that cycle, this line will be not used. Okay. So we will N35. Now I will take the second pass. Second pass is of 34, X34. Sorry, it is 37. 37. Okay, 1, 2, 3. En 40. Now again you have to give G01 inside minus 30. So it will take the second cut, second part. Okay. Now the third part of rough cut. So at this time you can use more feed also if you want. For the rough cut, you can increase the feed if you want 400, and for the finishing cut you have to increase this speed, and for the rough cut you have to decrease this speed. Okay, but you can increase the speed. Okay, you can increase the speed. You can write over here also. I will use S 1000 and F 300 for rough cut. Okay, 1000, and here also I will use the same. Yes, 1000, F 300. Okay. So no need to write this again because we have not changed the speed and feed. So G00 X again have to give 42 and Z2. So it will again come back to its starting position on year to year. So N50 again you have to give the feed for the third pass, rough cut, third pass. So X31, 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 N55. And now we have to give the cut G01 Z minus 30 speed and speed. Okay, speed and speed. Now now remaining will be, I will write over here. Okay, so N60 I will bring back to the starting point. G00 G00 X42 and Z2. Now from this it will cut the third rough cut, and again from this point it will move back to the starting position in this way. So at this block. The next one N65. Now you have to take the last and the finish cut. So for the finish cut, you can increase the feed and you can reduce the speed. So for that, use G00, don't require that. Directly you can write F30, 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 and in the next G01, Z minus 30, and speed you can decrease to suppose 500 RPM, and speed you can increase to 500. Okay. So it will complete this last finish cut. Okay. And now we have to stop this, again bring back that to the homing position, or you can directly give 75 G28 so that it will go back, or otherwise you can use to Z2. Okay, and then we can call for N80 G28. So then last way is that you have to stop the spindle. N85, you have to stop the spindle. So spindle stop is M05, coolant off is M09. Okay, and you have to change the program stop and M30 and program stop and. So in this way, multiple passes in the turning operation can be performed, and this retracting lines can be edited by using the turning cycle, using the turning CAM cycle code. Okay. So next, so in taper turning. So taper turning, how to when the taper is there. So what will be the difference in the programming line you will see in this example. So taper turning is a linear interpolation is there only. So there is no any radius. So in this problem, raw material given to you is a bar stock of diameter 20 mm diameter bar stock is given, and they have tell you that the operation involves facing. They have involved facing of the this bar stock. Then you have to perform the second one is the turn to 15 diameter, 15 mm diameter, 15 mm diameter over length, 15 mm length, 15 mm length. And the third one they have given, and the problem is that perform a taper turn. So I will explain that from this figure. So bar stock is given. Okay, so previously this will be in this way. Okay, a complete bar stock is there, and that is of diameter 20 mm, and the length is 35 mm. Okay, so you have to perform three operations, different operations they have mentioned. The first one is the facing operation, so facing of this. Then second one is the up to turning, you have to do up to 15. You have to make a simple turn operation. Okay, of diameter you have to change this 20 to 15. You can directly change, or you can include multiple passes. Then last one is you have to perform this taper turn. You have to perform this taper turn, and that is of 5 mm length. That is of 5 mm length. So, starting with the program. So we have given you this with the first. We'll do facing operation. Then we will turn that to 15 mm diameter, and from that point we have to take the taper turning. There will be no retraction of your tool. At this point, when our tool is finished this operation, and don't retract this again back to the starting position. Then again, you have to just perform the turning. Perform the turning. Okay, this step of turn at that point. So see. So first, again the same lines. I will write it fast. M05, G90, G71, G18, G94, G55. Or 54 to 59. You can take the AD code for saving this workpiece 0. If for 20 diameter of your clamp over the chair, it will take this 0 within the same length of 35 only, like the workpiece 0. Okay, then next one, we have to change the tool. So N10, sorry, N10, the tool change palette M06 T01. Then you have to start the spindle 103. The speed of, suppose I will take 1000 RPM the rotation, and the speed I will take. They have given the problem. It is okay. 200. Yes. Yes. Okay. 200 is given. F 200. Okay. They specify the tool number and they started the spindle over this block. N15. N15. You have to specify the starting position. So I will use the same X and 2 mm will be my Z. So starting position SP is 22 and 2. 22 and 2 is my point. So it is, suppose it is over here. Just over here. Okay, this is my starting position. Okay, so now give G00 X22 and Z. So now my tool will move over this coordinate position. N20. So they have given you the first operation to perform is a facing operation. So you have to bring that to the diameter first. So X20 I will take X20 facing operation for this as the dimension is 35. So 35 is given is the total length of that operation. 2 mm facing. Randomly I will take 2 mm facing. And then my 0 also changes. Okay, as I'm performing the facing operation, after the operation my 0 will change. Okay, the length of the bar stock will change. Okay, so X20, X20, XB, and you have to take X20. So now the cutting will happen when I will use the coordinate to Z0. Okay, X20. The cutting will happen when I will give Z. I will use 21. Okay. Okay. This position is also okay. So instead of this Z2, instead of this, I will use here Z minus 2. Okay. So now my cutter will move to this position. So now my cutter is over here and just 22 diametrically in X direction. Now the cutting will be happen by using the coordinate X because it is facing operation. So N25 G01 and now we have to give X0 so that it will cut the 2 mm. So this cutter will move in this way up to this 0 so that it will cut this 2 mm. It will face the surface of that bar stop by 2 mm. Okay, so at the time you can reduce the feed also. You can reduce the feed x0. If feed, suppose I will take 50. Okay, so speed is okay, 1000. Okay, so now now the tracing operation is completed. My tool is over this center point. Again, I will bring back to its starting position. N30, G00, G00, X22, and Z2. Okay, end of the block. So now again it will come back to the starting position. Okay, now N35, N35. Now I have to perform the first operation has been completed. Okay, now I have to perform the turning operation. The turning operation of 15 mm diameter. So the previous diameter of this bar stop is 20 mm. So to bring back the 20 mm, I will use angle cut. Okay, and the length is 15 mm. The length will be 15 mm. So for that, I will give x50, x50, x15. So now my cutter will move to the this diametrically, and now we are 40 G01, G01, Z minus 15. So now it will take the cut. Now it will take the cut and complete this. Complete it completes the turning operation. So at this time you can increase the feed. I will increase to 150. Okay, 150. Okay. At this point, now my cutter is over here. My cutter is over this position. Okay. Now at this position only, you have to take the taper turning. You have to take the taper turning. Now at this position only, N45, N45. The diameter is 20. So diameter is 20, and Z you have to take Z. So at this time, G01 will be remain same. Taper turning is there. So two coordinates will act. X20. X should be 20. End is at 20 diameter. So this portion you have to cut. This portion you have to cut now. Okay. So to remove this portion, you have to use two coordinates because it is it is in its angle. It is in taper. So that's why we have to use two coordinates in a single block. So x20, and z should be, instead of this minus 15, what is the length? Length is 15, and this 15 30. So this gap should be 5 mm. It is given also here, 5 mm minus 20. So that my cutter will move in this way. In this way up to this point. Up to, I will rub first so that you can easily understood that. Too much of, okay. So it will move in this way. Okay, and it will cut that portion over here. Okay, so end of the block. Now when it is at this position, at this point, now in N50, so starting position our G00, X22, and Z2. So it again come back to the starting position. Now you have to bring the homing position G28, to stop the spindle N60, spindle stop M05, and stop the coolant M09. Okay, and then you have to just end the program M30. So in this way, paper turning can be done. Okay, so at the end of the edge, when your tool is there and the taper is started, so at that position, taper. When my tool is at this position, that at that time only I will not retract that back to the starting position. I will use that position only to taper the workpiece. Okay, so this uh, threading operation is remaining, and the radius operation we will cover this in the next session. So how to give how to perform this threading and radius by using, in this we have to use K also. In both cases we have to use I and K, because J is not there, Y axis is not there, so I and K have to use in this, both the problems. So we will discuss this. Uh, Question regarding today's session, you can ask me, or you can text me in this, or you can post also of this session in this, so that we can discuss that points in the next session. Any questions? I will first download the attendance. 45 students are there. 44 students are there. Okay. Question regarding today's session, you can ask me. So I will tell you this part programming in the examination. They will ask you mostly if you guess your question paper out of 10, 7 times they will ask you, so 7 or 6 to 7 times they will ask you taper problem, sorry, turning operation manual part program. For manual part programming is used for ask for turning operation. Okay, and in some cases they will ask you cycle. Okay, so 40% chances of this milling operations and the drilling metals, so they will ask problem over this manual part programming. But 60% chance is that they will ask you over this turning center concepts. Okay, and 100% they will ask you APT programming is there, so they will ask you only and only of me. So APT programming is different and manual part programming is different. So we are going to look at APT programming also. So 60% you can guess that it is turning question will ask for manual part programming, and 100% they will ask you APT of milling operation. Okay, so that's all for today. I think there is no any questions. Okay, I will suggest one book for the CNC machines. That name is CNC machines. A simple small book is there. Textbook is there. That is of BS Pabla. So you can refer this book, CNC machine. Okay, by BS. Now he become a doctor. Doctor BS Pabla. Okay, so this and PM Rao, you know it. Okay, PM Rao, CAD CAM, you can use that. And for reference, you can use Z, Ibrahim, Z, CAD CAM book. Okay, 3 books are sufficient for this, all the syllabus of this CAD CAM. Okay, so what is this? Now I will end the session. So today is, I think, A batch is there for the practical. We will meet at that time at 2 p.m. sharp. Okay, thank you.